Hi 7th graders, how are we doing today?
Good.
Good, awesome. Today we're going to be learning about ratios and proportional relationships. So here are our standards that we're going to be covering today. It's going to be 7RP2. And our objective today will be, after watching the Khan Academy video and participating in the lesson, you guys and in small groups will apply proportional reasoning to a real-world context by creating a table showing the increase in the no-bake cookie recipe for 8, 16, and 32 cookies. All right, so before we get started, I have a little pre-assessment for you guys. First, I want you guys to number off starting at 1, and you're going to have to remember that number because that's how I will call on you guys to participate in the lesson. So
1,
2, 3, perfect. Okay. And also, can you guys tell me, how can you tell if two ratios are proportional? Yeah, Kennedy.
You could simplify one of the ratios down to the simplest form.
Sure, into its simplest form. I like that. Okay, so for example, 2 and 6 and 12 and 36. Are they proportional? They are, right? Okay, for sure. Why are they?
Because they have the same unit ratio.
Perfect. Okay, yeah, they both reduce down to 1, 2, how many? 1, 2, 3. Perfect. Good job. Okay, so for a little continuation, is this given table a proportional relationship? And if it is, can you guys tell me what the unit rate is? You can just write it down on a piece of paper, and then once you guys are done, you guys can give me a thumbs up, and you guys can tell me what you guys got. Okay, perfect. So, Sydney, what did you get for the unit rate?
I got 1 and 3.
1 and 3. Perfect, yeah. So the unit rate would be 3. Good job. And again, with what does a proportional relationship look like on a graph? Kind of look at the graph, and what does that graph have?
It crosses between 2 points at the same rate.
Okay, perfect. Yeah, exactly. So it's a straight line. No, every X input has a Y output. For sure. Good job. Okay, so yeah, exactly. So we're gonna just watch this little Khan Academy video on constant of proportionality. He's gonna give us a little bit more background on what we were just talking about. And while we're watching, just maybe write down a few things that you maybe didn't know about unit rate or constant of proportionality. So, make sure the volume's turned up. The audio, I don't know what the deal is.
I think we had a problem with that here before too.
Yeah. Is it this thing? I don't know.
Maybe if not, you could just skip it. You could just
Yeah.
play it and you could read the subtitles.
Sure, okay. Alright. So yeah, it doesn't look like our audio is working. So I'll kind of facilitate what Khan Academy is talking about here. So yeah, a constant of proportionality. There's several different ways to show a relationship between an input and an output. You can use a graph like we were talking about earlier, and you could also use a table or a chart. And like what Khan Academy is doing here, he is using cups of milk. So each cup of milk, 2 equals 2 eggs, I guess. And yeah, okay. So anyway, I wish the video would have worked, but it's all right. So the constant of proportionality in a proportional relationship is the constant of proportionality. So also known as the unit rate is the ratio of y to x, and it can be represented by the variable k, actually. So a proportional relationship is a relationship that exists between 2 variables, where one variable is a constant multiple of the other. And this means that one variable changes and the other variable changes in a predictable way. So on a graph, this can look like, it can be represented by a straight line that passes through the origin. On a table, it could be a proportional relationship will have a constant ratio between the 2 variables that after you simplify them. And in an equation, a proportional relationship will have a constant of proportionality, or the k, that relates to the 2 variables through the equation y equals kx. So let's work together on this little worksheet. We will do we'll do page 1 together. So I'll hand this out to you guys. We're just going to do numbers 1 and 4 on the first page, okay? So let's look at number 1. So if this table shows, or let's look at the directions, I guess, in a proportional relationship, the constant of proportionality, also known as the unit rate, is the ratio of y to x. It can be represented with the variable k, like we were talking about earlier. So we need to determine the constant of proportionality for each proportional relationship below. And we're going to write our answers in the line. Okay, so let's see, Cindy, can you read that first one for me?
This table shows the proportional relationship between the tablespoons of vinegar, X, and tablespoons of oil, Y, that Paul mixed together to make salad dressing.
Perfect. Okay, so let's look at those X inputs and Y outputs, and I'll give you guys a few minutes to work there. For the X and Y output, Avery, do you see the unit rate?
Yes. It would be 2, right?
No, so close.
3.
3, perfect, good job. Because, for example, we put X in for 1, the Y output is 3, and then we put 2 in for X, the Y output is 6, and yeah, exactly. So to write that as a equation, how would we do that? So the constant rate for that one is 3, right? So that's what our k would be. So k equals 3, and I guess for the equation, the y equals mx plus b, which we've talked about earlier, right? So what would be the equation for that problem?
Y equals 3x.
Y equals 3x. Perfect. Thank you, Sydney. It's a bad marker, but okay. So y equals 3x. 3x. Perfect. Did everybody get that problem down? Perfect. Okay, so let's look at that second one. Actually, because of time, we're going to have to skip to number 4. Okay, so let's look at number 4. The table shows the proportional relationship between the number of hours Josiah worked, X, and the number of dollars earned, Y. So I'll give you guys a few minutes. You guys can talk in your groups too to find the K for that one, or the unit rate. Good job. Okay. Awesome. Good job, guys. So
What plus X is the same for all of them, then it gives you
sweet. Okay. Okay. So Kennedy, what did you get for that question?
I got 15.
Perfect. Okay. How did you recognize it as 15?
Because I first looked at the X and the Y, 2 and 30, and I was thinking about what would multiply to get to 30.
Okay. Perfect. And that was 15. Gotcha. And that worked for every X input and output. Sweet. Good job, guys. That's exactly right. So that one's 15. And because of time, we're not going to be able to go through the rest of that first page together. But if you flip to the back, you guys are going to work together in your small groups to solve these problems. And when you finish, we'll check your answers. So we're just going to do number 7 and 8.
This table shows the proportional relationship between juice, juice, and total cost of juice.
It's gonna be 40 divided by 1.75. Table shows the proportional relationship between the amount of time and hours.
Hours.
And how did you know yesterday, X, and the amount of snow and inches? That fell, Y. So,
We have 2.
1 divided by 2 is 40. So Y equals 0.5X. Or 1/2 X.
Perfect. Okay. Yeah. Did you guys finish those problems together? Okay.
Yeah.
Sweet. So what did you guys get for number 7?
$1.75.
Awesome. Great job. How did you guys get to that? Did you set up an equation? Or yeah, Avery, what'd you do?
I divided 5.25 by 3. So
Oh.
the Y by the X.
Awesome. Perfect. Yeah. Great job. Awesome. And then what about for number 8? How did you guys go about solving that one?
We divided
Perfect.
1 by 2.
1 by 2. Yeah.
Or
Okay. Fair enough.
0.5.
Yeah. 0.5. Perfect. Okay. Perfect. Yeah. So the yeah. Great job, guys. So that constant rate is 0.5. Okay, so now for activity, I will hand out our recipe for no-bake cookies, and working in your group, you guys will identify the ingredients you will need to make the cookies. You will tell me how many cookies does the recipe make, and then you'll create a table that shows the amount of ingredients you will need if you want to make 8, 16, and 32 cookies. So here is the ingredients, and yeah, set up those equations and create a table that will show the amount of ingredients you'll need if you make 8, 16, and 32 cookies.
So, I think, does this make a dozen cookies?
8 cookies.
Oh,
So, 11 bake cookies.
just add,
Okay,
add.
16 times 8 is,
double.
8 plus 8 is 16.
okay, yeah.
So it's 8 times 2.
Plus 8 is 32, right?
Okay, so this grabs these for 32.
Yes. I don't wanna make these cookies.
Yeah, I know.
I will.
My bad.
Okay, you guys, okay, so, tell me guys, how, what did you guys table end up looking like? What, okay, sweet, let's see. For 8, you got one for perfect. So, sweet, okay, awesome guys, sweet. You guys did great there. And after watching the Khan Academy video or not, and participating in the lesson, students in small groups applied proportional reasoning to real-world context by creating a table showing an increase in the no-bake cookie recipe for 8, 16, and 32 cookies. So if you guys wouldn't mind just filling out your exit ticket before you leave and handing that in to me, thank you guys. Absolutely.